In this module we're going to talk about orphaned chunks, and orphaned is the name we've given them. It'll soon become clear why they are named as they are. First of all, there are two basic types of orphaned chunks. First of all, there are temporary, and then there are permanent. And we'll draw out a quick diagram of a sharded cluster and explain how the two different types come into being. So let's do that. Okay, so we've covered in detail how the migration process works, and as part of that we went through like the many steps involved in that migration. What we showed then was a chunk being moved from shard 1 to shard 2 and the various stages that were contained therein. And the orphaned data in this scenario, if you like, is the one that we've already explained. It's covered by the fact that there's chunk managers on these primaries. This is the shard 1 primary, the shard 2 primary. There are chunk managers on here that will filter out the results if they receive a query for a chunk they don't own. But that doesn't mean that the data isn't there. So temporarily, particularly during an in-flight migration, so this is actually in flight and happening, there will be data for this chunk in two places. And it won't go away until the background delete completes on this shard 1, the source shard. So while the migration's in flight, there can be orphaned documents in two places, and there's only one owner of a given chunk at any time. Hence, while these are being transferred over, during the in-flight migration, this is the home, the official home for that chunk. But some of the data is over here on shard 2. We've started the transfer process, and some of the data is already on shard 2. So say it's about half full. So this sort of 50% complete transfer, these are the orphaned documents. So that's the first one, and we've already kind of covered there's a chunk manager running on each one of those. Shard 2 knows that if it does get a query that applies to the this particular chunk, that it does not own it, and hence the results will be filtered out. So it's not a big deal, and we do also know that eventually this will become the owner, and this will become the home of this chunk, and then it'll be deleted here. Which brings us nicely to our sort of permanent version. So this is the temporary version, because it's in flight. These are temporary situation. They're temporarily orphaned. But what about the permanent ones? Well, there's a couple of ways that the permanent ones come about. So let's cover those two scenarios. You got the shard 1 primary, and we got the shard 2 primary. We got our MongoS up here, and this is the MongoS that's kicking off the chunk migration. We're going to use the same orange color to represent the chunk that we're talking about here, and we're going to assume that once again we have an in-flight migration going on from shard 1 to shard 2. And something goes on here, because as we mentioned, although we focus on the primaries here, this is probably a replica set with two secondaries, as is this. So these are actually replica sets. So what happens, the primaries are doing all the work. We've got an in-flight migration. This one is currently reading data off of the source shard and writing it locally itself. It's doing the W majority to make sure it makes it to the secondaries and everything else. But this operation here, the actual transfer and the actual migration piece itself, is specific to these two processes, right? So the MongoD that is the primary in shard 1 and the MongoD that is the primary in shard 2 are the only ones that are really aware of what's going on. So let's say that disaster occurs, and let's say that this primary for some reason crashes, it's rebooted, something happens so that it basically goes away while this migration was in flight. Well, we know that what's going to happen from the replica set perspective is one of these will be elected, step up to primary, and then eventually this one will be restarted and come back in as a secondary. The new primary has absolutely no idea that this migration was going on. So this in-flight migration is essentially aborted. So an in-flight migration has been aborted. However, some portion of the shard has actually made it, and it's actually been replicated. So let's say 50% of it. Again, we'll just go with 50%. So 50% complete transfer, but the migration was aborted. Now it could be that the MongoS will say, oh well, that's terrible, what we're going to do is retry that with the new primary, start it all back up again, the new data gets transferred over and it all gets cleaned up. But what if that's not what happens? What if something else is taking a higher priority in the meantime? You've got 50% of a chunk over here. It is orphaned. This is not its home. because the migration never finished, this is still the home for this chunk on shard 1. So that 50% of the chunk that got transferred over is orphaned, and it's there. Now, we've already covered that these orphaned chunks will be filtered out, but it's still a chunk of data, pardon the pun, that's been written onto this shard without belonging there. And you can imagine if this happens a lot, or if there's something else which causes in-flight migrations to get aborted with partial data transfers, you get a lot of build-up of data here that is not necessarily wanted, right? And so it's wasteful of space, and it might cause some problems. In fact, there are a couple of bugs related to orphan documents. Orphan documents, and this may be fixed in 2.6 and maybe fixed in later releases, but orphan documents are often counted by the count command. For efficiency, the count command bypasses certain logic on the shards, and as a result will occasionally see some of these, both the temporary ones and the permanent ones, depending if you have any permanent ones. If you've never had an aborted migration, or the one other scenario that we'll go through in a second, then you won't have any permanent orphan documents. But even if you don't have any permanent ones, the temporary ones that occur during the in-flight migration may cause count to count them twice. That's why with an in-flight migration you might get one value with a count, and when the migration is finished you may get another. So that's a known bug. It's been worked on, but I'm not sure if it's fixed in 2.6 or not yet. It will be fixed in a later release, but it's a sort of a known issue with counts across a distributed sharded cluster. There's also the fact that if you don't connect to this primary through the MongoS, you always should. You always should connect to the primary through the MongoS. If you do connect to it directly, you'll see these orphan documents, because there's no sharding mechanism, there's no chunk manager in here to say, I don't own that. It's just data as far as this MongoD is concerned when you connect to it directly. So orphan documents can cause problems. They're also on the secondaries, and secondaries don't have chunk managers. So if you're doing secondary based reads, orphan documents may show up. So there you go. Orphan documents can be double counted on occasion. Orphan documents can show up if you connect directly to a replica set that's part of a shard, and orphan documents can show up if you do secondary reads. So there's several scenarios there where they can throw a spanner in the works and become a bit of a problem. They also waste space and other things like that as well. So they're generally an undesirable thing. So first of all, are there any other scenarios where they occur, and then we'll get on to what to do about them. Is there any other reason why you might end up with orphaned documents? And the answer is yes. And it's we've concentrated on the target shard here for a second, for the most part, for the first couple of things. But instead, let's say that on the source shard, target shard doesn't come into this one, so we won't redraw it. The source shard is sending a chunk somewhere. It's been told by this MongoS, send that chunk over to that other shard, migrate it over. Perfect. So it does that, and the migrate is successful. Excellent. So we get a smiley face for that one. So the migrate is successful. This is no longer the home for that chunk. So these are now orphaned until they're deleted. We cover this as part of the anatomy of a migration section. There will be a background thread started off to delete these. So delete. So there's a thread kicked off to delete these in the background, and if that completes, all the orphan documents are gone. So they're there for the duration of the delete. So we've got another sort of scenario where you get your temporary orphan documents. But again, what happens if that primary steps down? This background delete thread only existed on the primary. It's not running on the secondaries that are down here, because when the deletes happen, they'll be put into the op log and they'll be propagated to the other secondaries. So this delete thread only exists on the primary. So if the primary steps down, same thing's going to happen as we saw before. One of these will step up, become primary, and eventually when this is brought back up, it'll rejoin as a secondary. This new primary has no knowledge of this delete operation. And because the delete never finished, it still has some amount of those documents on there. So what should have been temporary orphan documents, so these would have been temporary orphan documents up here, become permanently orphaned here. There we go. So that's the other sort of scenario where you end up with orphan documents. Now, if you're not having your primaries crash all the time, or you're not having aborted migrations all the time, you basically won't have any orphan documents. So they're not considered a part of normal operations for a sharded cluster. However, they do happen, and so we've had to take steps to mitigate them with things like the chunk managers filtering them out.